Okay, guys. So in the last class, we did types of quadrilaterals. Remember,
Yes,
I
sir.
told you kite, rhombus. I told you all of the quadrilaterals.
Yes, sir.
Okay. Now moving on with further part. So these theorems we did. Okay. So now we have example two. Show that diagonals of a rhombus are perpendicular to each other. Okay. So let's do this question.
Yes, sir.
They are saying we have to prove that diagonals of a rhombus are perpendicular to each other. Okay. So what I will do is I will make a rhombus. This is example two. I'll add example two. Show that diagonals of a rhombus are perpendicular to each other. Okay. We have a we'll make a figure first of all of a rhombus. Okay. Now I'm gonna name this as A B C D. Okay. We know that given is AB is equal to BC is equal to CD is equal to DA. Okay. But say if I name this point as O, we also know that AO is equal to so this all I'll write later. So first of all, starting with the proof. Okay. What I'm gonna do, I'm gonna take two triangles. Okay. I'm going to take two triangles and let's take the two triangles as let's take the two triangles as AOB and triangle COD. So in triangle AOB and triangle COD, okay, hey, see here also we have taken these two triangles, triangle AOD and triangle. So I wrote the name different AOB and COD, AOD and COD. They have taken these two triangles. Okay, okay, fine. We have taken these two. We can do it by that way also. Let's that would be better. Let's do it by that only. Let's take triangle AOB and this triangle. I'm going to take these two triangles, guys. First is this one. Okay. First is this one. Second is this one. I'm going to take these two triangles. So this is triangle AOB and triangle AOD. So in triangle AOB and triangle AOD. Okay. We know that AB is equal to CD. AB is equal to AD. Sorry, AD. AB is equal to AD. This is given. Sides are equal of a rhombus. Sides are equal in a rhombus. Sides are equal in a rhombus. Okay. And we know that this AO is equal to AO by common. AO is equal to AO was common. Okay. And we have BO is equal to DO. They are equal to each other by AO. BO is equal to DO. They are equal to each other because diagonals are bisectors. So if diagonals are bisector means AC bisect BD. So BO would be equal to DO. So diagonals of a parallelogram are bisectors. And since rhombus is also a parallelogram, so we can say that diagonal of a parallelogram gram bisect each other. Okay. Now we have proved these two three sides equal to these three sides. We can say triangle AOB is congruent to triangle AOD by SSS criteria. Okay, we can say that these two triangles are SSS. Okay, once we have proven them congruent, bache, we can say that angle AOB is equal to angle AOB is equal to angle AOD. Angle AOB is equal to angle AOD by CPCT. Okay, once we have proven them equal, okay, now I can see, bache, angle AOB plus angle AOD would be 180 because of linear pair. So angle AOB plus angle AOD is equal to 180. The reason is linear pair. Okay, so bache, I know that AOB is equal to AOD. So let them both be equal to X. So AOB is also X. AOD is also X. X plus X is equal to 180. 2X is equal to 180. X is equal to 180 by 2. That is equal to 90 degrees. Okay, so X is coming as 90 degrees, and this is what we needed to prove that diagonals are perpendicular to each other. If this is 90, bache, we know that this would also be 90. This we already proved that 90. This would also be 90 by vertically opposite angles. So means they are perpendicular to each other. Is this clear to you all?
Yes, sir.
Yes, sir.
Okay. Write this down very carefully by understanding each and this thing. Okay.
Done, sir.
Okay, Umar. Adrian, you are writing it down?
Yes, sir. Writing.
Okay, okay, write it down. Adrian, are you done, Bache?
Yes.
Okay, great. Moving on, we have ABC is an isosceles triangle in which AB is equal to AC. That is bisect AD bisects in exterior angle PAC. Okay. So without even reading the question, now what I'll do is I will first draw the figure. They are saying ABC is an isosceles triangle in which AB is equal to AC. So ABC isosceles triangle AB is equal to AC. AD bisects exterior angle PAC. Okay. We are saying they have an exterior angle. This is P. So this is an exterior angle PAC. AD bisects this angle. Means we have another line AD which bisects this angle. So means this is X, so this would also be X. Means bisecting means dividing into two halves. Angle PAC and CD is parallel to CD. Okay, CD is parallel to AB. Okay. And they are saying that this point C, sorry, D. Let's say D we have. So this point D Consider the point to be here. White pen, white. Okay, consider it to be till here. Okay. So now we have, this is the figure. Okay. I hope you understood the figure first of all. They are saying show that angle DAC is equal to angle BCA. DAC. We have to show this angle is equal to angle BCA. So this is equal to angle BCA. Okay. Find this angle. Secondly, so we have to show. So first of all, what all is given? Let's see that. We are given that AB is equal to AC. This is the given. I'm writing the given part. AB is equal to AC. And we know that angle PAD is equal to angle CAD. Okay. Then we have, what else is given? We have CD is parallel to AB. CD is parallel to AB. CD is parallel to AB. So this line is parallel to this line. Okay. Now they are saying that we need to prove that first part we need to prove.
So CD is parallel to AB, right?
Yeah, sorry, AB. Thank you, Arjun. CD, to prove, we have to prove angle DAC is equal to angle BCA. Angle DAC is equal to angle BCA. And we have to prove that ABCD is a parallelogram. Okay, fine. So this was the first thing. Second, we have to prove is ABCD is a parallel. If you did this much, means you understand the question. Okay. Now we have to apply and see how to solve this question. Guys, first part is we have to prove that DAC is equal to BCA. Means we have to prove that this angle is equal to this angle. Means they can only be true when they are alternate interior angles. So in short, we have to prove that AD is parallel to BC. Okay, we have to prove this. How can we prove this, Bachchan? See, very simple. I know that if AB is equal to AC, then if AB is equal to AC, then this angle and proof. If AB is equal to AC, then angle ABC would be equal to angle ACB. Angle ABC would be equal to angle ACB, right? This is this is of the theorem that angles opposite to angles opposite to equal sides are equal. Angles opposite to equal sides are equal.
Okay, sir.
I didn't you know this theorem?
Yes, sir.
Okay, great. Equals. Okay, because this side is equal to this side means this angle would be equal to this angle. Okay, we have
Yes,
to
sir.
prove this much. Okay, now I know that angle PAC would be equal to angle ABC plus angle ACB, right? Because exterior angle property. Because this is an exterior angle, this is actually a straight line. Sort of straight over here. This is straight. Okay, it's kind of straight. Okay, so since PAC is the exterior angle, so angle PAC would be equal to angle ABC plus angle ACB. Exterior because of exterior angle property. Exterior angle property says that the exterior angle is equal to the sum of opposite interior angles. Any doubts in this, Umar, Adrian?
No,
No,
sir.
sir.
Okay, okay. This angle is equal to sum of this and this. But say ABC is equal to angle ACB. So let that be equal to x. So means angle PAC is equal to अच्छा ठीक x नहीं करो एक काम करो instead of this one angle ABC is equal to angle ACB. So instead of angle ABC, write angle ACB only here. So angle PAC would be equal to, instead of angle ABC, I'm writing angle ACB. So angle ACB plus ACB again. Okay, this is from 1. from 1. From 1. Okay. Now, angle PAC would be equal to ACB plus ACB, that is twice of ACB. Okay. Name this as equation 2. Fine. Now, but angle PAC I can write as angle PAD plus angle DAC, right? Angle PAC I can write as angle PAD. This angle plus this angle, this total angle, I can write as this angle plus this angle. Okay, so angle PAD is equal to, sorry, angle PAC is equal to angle PAD plus angle CAD.
DSC.
Yeah, DAC, whatever you can write. Okay, so angle this is equal to angle PAD plus angle DAC. Angle PAD plus angle DAC. Okay. Now, but instead of angle PAD, because they both are equal, angle PAD is equal to angle CAD, this is given. So instead of PAD, I'm going to write DAC again. So angle PAC is equal to PAD, instead of PAD, I'm going to write DAC again, angle DAC plus angle DAC. But so angle PAC is equal to DAC plus DAC is twice of DAC, angle DAC. Okay. Now, but this is 3. Now, angle PAC is equal to 2 i's of ACB, angle PAC is equal to twice of DAC. Both are equal. So putting 3 in 2. Okay. Instead of PAC, I'm going to write twice of DAC. So twice of DAC would be equal to, equate this to here, twice of ACB. Cancel this, cancel this. So angle DAC is equal to angle ACB. But see, this is what we actually needed to prove in the first part, that BCA.
Yes, sir.
Yeah, same thing. Angle DAC is equal to BCA. We had to prove this, so we just proved this, that angle DAC is equal to BACA or ACB. That's the same thing. So this was the first part proved. Got it, guys?
Yes, sir.
Yes,
Umar?
sir.
Okay, fine. Now, but if these two are equal, they are alternate, because we just proved these two as equal. This equal to this. So if I prove them to be equal, now they are actually alternate interior angles. Okay, so angle PAD, angle PAC, and angle BCA, or angle PAC and angle ACB are alternate interior angles if they are alternate interior angles, means that this side is parallel to this side. AD is equal to AD is parallel to BC. So AD is parallel to BC. AD is parallel to BC. Okay, so AD is parallel to BC, and we already had AB is parallel to CD, and AB is parallel to CD. AB is parallel to CD. This was already given. AB is parallel to parallel to CD.
So this is the second part, right?
What, bache?
Is this the second part?
Given part, given. So yeah, second part. Yeah, second part.
Okay, sir.
Okay. Okay, so this we prove. Therefore, we write interior angle. So therefore, AD is as parallel to BC, and this was given. So, bache, now AD is parallel to BC. We proved AD is parallel to BC, and this was already proven. This was already given. AB is parallel to CD. So, bache, therefore, this is a parallelogram. Since now we write, since the opposite sides are now parallel, the opposite sides are now parallel. ABCD is a parallelogram. Is this clear to you all?
Yes, sir.
Yes,
Adrian,
sir.
any doubts? Okay. Okay, this was way too big. First write this much, then you can ask me to slow it down. Okay.
Yes, sir. Done, sir.
Omar, are you done as well? Should I scroll it down?
Yes, sir.
Okay. Now write the rest of the part.
Done, sir.
Okay, Omar.
I'm also done, sir.
Okay,
No,
Adnan.
sir. Last line, sir. Just
Okay, okay.
Done, sir.
Okay, Adrian. Now, Bache, moving on, we have two parallel lines L and M are intersected by a transversal P. Show that the bisectors of the okay, okay. See, guys, they are saying two parallel lines. Oh, this is how the scale works. Okay, we have two parallel lines. L and M. They are intersected by a transversal P. Yeah, fine. They are intersected by a transversal P. Okay, now what they are saying is that this is L, this is M, this is P. Okay. Now they are saying that show that the quadrilateral formed by the bisectors of the interior angles. So interior angles are this, and this. So first of all, let's talk about this angle, which is yeah, this angle. So the bisector would be this, not like this. Then not like this. So this angle is like this. So the bisector would be like this. So for bisector, yeah, we have this. The bisector of this would be this. We have this line. The bisector of this would be this, and we have this one. So bisector of this would be this kind of, yeah. So we have to prove that. Let's name it. Now let's, if I name the triangle, if I name this figure, this one. First of all, the figure I'm talking about is this. Is this clear to you all? This figure, this
Yes, sir.
quadrilateral. Okay. They are saying this quadrilateral is formed by the bisectors of the interior angles. Bisector means cut the angle in half. Okay. So we have to prove that if I name this as A, B, C, and D, we have to prove ABCD is a rectangle. Okay. How do we prove ABCD is a rectangle? First of all, we have to prove that the opposite sides are parallel and equal, and then we have to prove that the all angles are equal to each other, or we can say that they are 90 degrees each. Okay, this is what we have to prove. Okay, so now let's solve this question very simply. Okay, first of all, so let's see how the first of all in the book was there various or different way. The way I'm seeing the bisector of angle PNC. Show that the angle PSC. PS is equal to QR. That's what I'm thinking. No, PS is equal to QR. PSC is equal to PSC and angle ACQ intersect at B. So that's clear. That's in PSC, ACR, alternate interior angles. You know this. Hmm. Yeah, same way. That's what I think. Okay, fine. Guys, first of all, look at angle. I'm gonna name this as PQ. I'm gonna name this as RS. Okay. Now, guys, angle QAC, which angle QAC is equal to angle RCA. Okay.
Sir, but
The reason is
the line below is already named as M, right? The left is M, right? M is right.
which is the line is named. I'm naming some points so that it's easier for me to name the angles. Okay. Line is already L.
Okay, sir.
Line is infinite. I'm naming points. Okay.
Yes,
Alternate interior angles. The reason is alternate interior angles.
yes, sir.
No, angle QAC is equal to angle RCA. Now, bache, these are equal because of alternate interior angles. So this means that half of angle QAC would be equal to half of angle RCA. Say, okay. Now half of angle QAC I can write as ACB because they are saying that it divides it in half. These are the bisectors. So half of angle QAC I can write as angle uh, ACB. This angle. Okay. Half of angle QAC. Sorry, QAC is this one. Half of angle QAC I can write as this DAC. Okay. So angle this is angle DAC. So this is equal to angle RCA. Half of angle RCA is angle BAC. Sorry, BCA. Angle BCA. Is this clear first of all?
Yes,
Omar, did you get this?
Yes.
Okay. Now, okay, these two angles are equal. Similarly, I can prove. No need to show the full. Just write similarly. Angle BAC is equal to angle DCA. Similarly, angle BAC is equal to angle DCA. Okay. Since bache, this angle is equal to this angle, they are alternate interior angles. So AD is equal to BC. Okay. So therefore, since angle DAC and angle BCA are alternate interior angles, AD is equal to BC. So AD is parallel to BC. AD is parallel to BC. And since angle BAC is equal to angle DCA, since angle BAC and DCA, since angle BAC, BAC and DCA are also alternate interior angles. So we can write that BC is parallel to AD. Sorry, AB is parallel to CD now. AB is parallel to CD. AB is parallel to CD. Okay, we have proved them parallel. So since AB is parallel to CD and AD is parallel to BC, the opposite sides are parallel. We can say that ABCD is a parallelogram. Therefore, ABCD is a parallelogram. Clear? Is it clear, guys?
Yes, sir.
Okay. We have proved this to be a parallelogram. Now they are saying that we have to prove that it is a rectangle. Okay, so basically we have to prove that any of the angles is equal to 90 degrees. So we will be able to prove that all of the angles are equal to 90. Okay. So now, guys, using that, how we can prove that? Let's see how they have used in the book. My way is longer. Please form a linear pair of organic. Here, so they have proved it. Angle PAC plus angle CAS. PAC plus angle CAS equal to 90 linear pair according to the. Mm-hmm. And since the book way is easier, it might confuse you. CAD. नहीं नहीं book way is difficult. See, guys, what we can do here is take. I will prefer take this one. Okay, take this angle. Angle B. This would be easier for you. Angle RCA plus angle CASCA. Their sum is 180 because of linear pair. I am writing here, bache, so that easier. Angle RCA plus angle SCA is equal to 180 degrees. Okay. Now, bache, multiply the whole equation by half. So half of angle RCA. This is the reason is linear pair plus half of angle SCA equal to half of angle 180. Okay. Half of angle RCA would be angle BCA. So angle BCA plus half of angle SCA would be angle DCA. So angle DCA is equal to 90, which is if their sum is 90, okay, so means angle BCD is equal to 90. Therefore, angle BCD is equal to 90 because angle BCD is equal to angle BCA plus angle DCA. So angle BCA plus angle DCA, that is equal to 90 degrees. Okay, once we have proved this angle as 90, opposite angles are equal. So this is also 90. Okay, so therefore angle BAC, angle BAD is also 90, angle BAD so equal to 90, vertically opposite angles. Okay, and at last we have angle ABC is equal to also 90, and before angle ABC is equal to angle this one, angle ADC goes as 90 because adjacent angles are supplementary. Okay, so that one was 90, so this would also be 90 because 90 plus 90 is 180 are supplementary in parallelogram. So which is therefore it is a rectangle in parallelogram. Okay, so therefore ABCD is a rectangle. Therefore ABCD is a rectangle. I hope this is clear to all of you.
Yes, sir.
Umar, did you get this?
Yes, sir.
Okay, but this was a very long question. I understand. Okay, so I'll you can write this in the next class. Okay, because the class is over.